Hello everyone, how are you going? And welcome to the Bay of Fundy's world-class tidal resource, something that absolutely makes sense knowing how much water moves through there, but how do you actually harness that?
Hi, I'm David Dodge. Welcome to Green Energy Futures. This week we're off to the Bay of Fundy in Nova Scotia to experience the full force of one of the highest energy tides on Earth. The dream of harnessing large-scale tidal energy is very compelling.
Wow.
If it's going to happen anywhere, it's in Nova Scotia. They've got the Fundy Ocean Research Centre for Energy, or FORCE. It's Canada's leading research centre for in-stream tidal energy, and it's right on the Bay of Fundy. We went out in the water with Matt Lumley of FORCE to experience the power of the Bay of Fundy.
Oh man, before they get into it too much, I just want to take it back to the size of these turbines. Look at that, they have a little scale model of a blue man, but my god. I mean, I guess to be fair, with the entire scale of the ocean, the amount of water that moves in and out of the Bay of Fundy, you can definitely afford to go big or go home, and they definitely did not go home with this one. And I guess that was only one of the designs, as we can see one that looks fairly built. It also looks kind of rusted, but there we go, there's another one of the many different tidal generation designs. Look at that. That is a lot less, well, I don't know if it's smaller. I was going to say smaller, but you really can't tell. And to be honest, it almost looks as though those massive big backstays are almost tower crane sections, and so that is no small thing. You certainly would not want to be swimming through there. I mean, they don't want to be harming any wildlife, but either way, it would be a massively frightening sight to see those blades, 20 meters wide or whatever they are, just spinning in front of your face.
The most recent model suggests we've got about 7,000 megawatts of potential here, and we can safely extract about 2,500 megawatts. To give you an idea that the maximum peak capacity in Nova Scotia is about 2,300 megawatts. So we have more power here than all the power that Nova Scotia demands on its coldest day in the winter, when everyone's home with the lights on and the furnace running and the engine on. There's more power here on a peak flow than all that demand.
Well, geez, it really does start to be put into some serious perspective when you hear that an entire province can be powered by the ocean. And I mean, it also just puts into perspective how much power and energy potential this planet has, you know, from solar, from the sun, to harnessing all these different little elements as well. There is so much energy, and we just end up burning things just to make our energy most of the time anyway. It's like, what are we doing? It's all there. As long as, like you said, we can safely extract it, there is nothing wrong with it. And the oceans is such a renewable resource, literally, until the moon in about what, like a billion years or so, just leaves Earth entirely. I think we're going to be having plenty of tides in the Bay of Fundy, especially given the fact that it sounded as though it was a fairly conservative extraction percentage. You know, he said 7,000 total, which is just a monumental amount of power compared to 2,500 is what they are kind of aiming to take or think they can safely take. And that is the other part of the puzzle that I was wondering about. What is the population of Nova Scotia? But as it says, 1 million people, and so to be powering, let's say, 1 million people off just some water flowing through a turbine, that is pretty impressive from one location. I mean, it's a big location, it's the entire ocean, but still pretty impressive when you can even do that.
We're in the Minas Passage. Here the shoreline and the seabed pinch in, and the water goes from moving at 1 meter per second to 5 meters per second. It's akin to taking your thumb and squeezing the end of a large garden hose.
Look at
As you can see, this is challenging, but also exciting. The challenge is to do any kind of marine activity, to put in a tidal turbine, to retrieve a tidal turbine. It's one of the hardest places in the world to do that. It's also exciting because if you can do it here, you can really do it anywhere. So this is really the ultimate proving ground, both for tidal technologies and the industry itself.
That is insane.
Whoa!
Shortly after this, our Zodiac was swamped by a big wave, a testament to the power of the Fundy tide. Once we got off the water, Matt Lumley explained the history of tidal technology and where it's going.
Look at that shoreline. There is nothing left of it. Everything has just been swept away by these incredible tides. And I mean, I guess that is also just the local geology, but God, there's not a piece of sand anywhere. But no, in relation to what they were just talking about, that is the biggest shame with tidal generation. The fact of the matter is that you have to build in these just ridiculously challenging environments in order for the end product to be any water efficient, because, well, you need the water flow, but that just makes everything so difficult, especially when you see just even the little waves and how choppy it is, let alone the fact that you can't really anchor in 5 meter a second water. That That is so fast. Especially given the fact that if we just come back and even look at the size of it, you know, how do you anchor this thing to be able to work on it in the first place? You put a piece on the water and you try and drift it into position, but you just miscalculate it, and all of a sudden it's just across the other side of the ocean because, like I said, it's traveling at 5 meters a second. You have so much resistance, and that's once again what you want because you need that to be able to drive the turbines, but not as you were trying to build the entire thing. And so I don't know if they can engineer it to kind of turn the blades along their y-axis so it has a lot less resistance. Either way, the fact that you just got that much surface area in the water is going to get pushed around, and so that would be so challenging, let alone even just getting it up there.
Nova Scotia already lays claim to one of only 3 tidal barrages in the world. That's like a tidal dam, much like a conventional hydroelectric dam where you simply build a dam across a tidal race and generate power. That is still in operation in Annapolis Royal, and when it's in operation, it generates about 20 megawatts of power.
20. Wow.
There are impacts.
Those impacts can affect the coastline and its ecosystems in a drastic way. So much so that these tidal barrage systems aren't much in favor anymore.
What we're looking at is a new type of technology called in-stream, and it's called that because it's literally placed in the stream of the current, much like a windmill under the water.
Honestly, just coming back to, there it is right there. Look at the size of that fan. I mean, I can only imagine it weighs a lot because look at the size of that crane as well. I mean, I guess you certainly don't want to be sending people down there to fix it every 2 months and just weld a new plate on, but God, that is a huge, huge piece. I mean, I guess to be fair, there are so many different reasons why you do want a fan blade that big, and of course the number one reason is just so you can move enough water and generate enough power, but it's also because when you have a blade that big, you don't have to spin at 1,000,000 RPM and just turn it into a massive spinning blender underwater. For goodness sake, as he was talking about, these original kind of hydroelectric schemes do have their problems because you were damming and undamming and damming and undamming, and I believe that there was even having whales getting caught in them and all those kind of things. So it absolutely makes sense as to why you would want to be looking into this in-stream technology. For one, you just get to use the entire Bay of Fundy instead of these little kind of estuaries and canals and things in comparison. As for goodness sake, if nothing else, he said that these only generate 20 megawatts compared to the entire array of them being able to just extract 2,500 over 100 times.
The Fundy Tidal Research Center has demarked an area of the Bay of Fundy. The environmental assessments have been done, and there's a grid connection. This is where some of the most promising in-stream tidal power technologies are being tested. In one of the first projects installed, the problem was not the technology, but that they actually underestimated the power of the tide.
What had happened was the turbine went through one spring tide cycle where the power is the greatest, and on the second spring tide cycle, the blades had blown out. The reason they lost those blades is that that unit was operating at about 2.5 times the anticipated power output.
Whoa! 2.5 times what they expected. You know, you got all of these smart people designing it and manufacturing it and just making sure everything is going to work, taking surveys of the area, speed tests of the water, all these different things, calculating every little angle, and they end up having 2.5 times what they expected with all their mathematics. That is just ridiculous. It really does show you how much power is just lurking in the water, and honestly impressive that whales and things can even be in there. I mean, maybe they just go in there because they don't even have to swim. They just literally sit in the water and it just takes them down and then takes them back out 6 hours later. That is insane. Either way, like I said, the fact of the matter is that you cannot be sending an entire crew to go down and service it, let alone to send an entire brand new propeller there every 6 months or every year, whatever it may be. You need these things to, yes, have maintenance and checks and things, that's fine, but not to have to replace them every year because the tide was too strong. And I guess in some ways it is a really good problem to have because you have excess power to a factor of 2.5, and so you go, okay, let's just change the design because it doesn't have to be ultra efficient. We've got plenty there. We'll just put more in and make sure that they last instead of just trying to get every last percentage out of it because it's all there already.
The reason they lost those blades is that that unit was operating at about 2.5 times the anticipated power output. That's how little we knew about the resource when we started here, and every day that goes by, our research is showing us more and more of just how powerful this place is.
There are plans to deploy several other technologies at this working in-stream tidal energy site. Not only does Nova Scotia have the Force Research Center, it also has a feed-in tariff ready to support viable tidal energy projects. John Woods is with Minus Pulp and Power, a company that's working to harvest tidal energy in the Minas Passage.
This represents one of the technologies, and we have a plan that will have an array in place by 2015-16, delivering energy at about 12.5 cents. Now, with that comes an industry. The Bay of Fundy isn't about electricity. It's about creating an industry unlike anything else we've seen in the past. 2,500 megawatts at a $5 million a megawatt capital cost is a $10 billion industry with about a $300 million a year maintenance industry.
To learn more.
Okay, there was a lot of numbers that were just thrown around there, but 10 billion as a 300 million, that is definitely a good ratio to have. But I just want to go back to that cable because that thing was insane. And I was also blown away by the fact that I hadn't realized how old this video is. It is 9 years ago this video came out, and so I can only hope or assume, or I don't know what, that a whole bundle of these have been deployed. I mean, I haven't heard anything about them. Maybe they're still losing blades because they're still just getting caught off guard by how powerful the entire thing is. But either way, man, that is a lot of power, and it's good to hear that they have multiple different issues and deployments just on board because, well, you're gonna need it. And honestly, coming back to this cable, that is an entirely different problem that they would have had to solve. How do we make a cable? I mean, yes, there are obviously deep sea cables already, and so I'm sure the technology exists, but for this one particular application, how far do they have to make this power travel? And then all the transformers and all those different things to be able to make it travel long distance. It is such an engineering nightmare in some ways, but such an engineering challenge, and so everyone would love it as well. I also wanted to come back and double check it because I saw as it was going past, a 400-ton gravity base. I can only assume that that means that this guy had a 400-ton gravity base. That means, what, not actually affixed to the sea floor, just using weight? I mean, in the Bay of Fundy, I feel as though that's kind of betting on the wrong horse. And even though if we do continue reading on, we see that this is the one that lost its blades as tidal forces at the site greatly exceeded modeling and popped the turbine from the 6-meter diameter rotor. That is a pretty impressive thing to do in the first place, but like I said, no oils and lubricants. They really are trying to consider so many different factors in this. That is awesome to hear. And so considering that we saw that that video was 9 years ago, I have to try and look and see if any other progress has been made. Here we go. Let's just take the first one. Has there been any progress made? Oh, actually look at that. That is pretty cool. Oh, it just lowers it into it, and wow, that thing is moving. No, you definitely would not want to be in that path, but geez, that is a smaller one than I thought. I guess it's just on a hydraulic ram. God, that is actually a bit of a blender, more than I thought. Either way, that's a smaller one, and so I guess the bigger you go, the slower it will spin. And look, even just briefly skimming this entire article and then even just looking at this image here, it is interesting to me, or also just confusing to me. Why are you starting with the Bay of Fundy? I understand the entire thing of, okay, if we can do it here, we can do it anywhere, but maybe make sure you can even do it before you even see if you can do it in the Bay of Fundy. Surely if you're just breaking turbines, rein it back in a little bit, then develop the technology to be able to survive in the Bay of Fundy. Look at this incredible photo of that cable though. That is insane. The amount of shielding and layers of it. I don't even know how you go about making a cable like that, between all the different layers having to line up obviously and being able to actually sleeve the thing, to inserting steel, just wrapping it around, and then the fiber optics that are in the middle as well. There's so many things going on. And it says actually over here, a sample cross section of a 34,500 volt submarine cable on display at Force, who were the people that designed that cable. But look, if nothing else, I do have to applaud the willingness to attempt such an incredible feat. Like I said, from the cable design to the cable implementation, rolling that across the sea floor, to then of course the main meal that is the turbine itself, and all the iterations and designs and companies that have put their time and energy and resources into designing such an incredible thing, because, well, it's an incredible resource that if we can harness it correctly, is amazing. Just ditch all that coal out of Nova Scotia and just give it some water instead. But anyway, insane that. I reckon I'm going to call it there. So thank you for watching this video. If you did enjoy it, feel free to the YouTube algorithmic things down below. Also, if this is the first video of mine that you are watching, then make sure to go check out any other ones I've done. Also, make sure to go check out the original video down in the description below. Or hey, maybe even just want to consider subscribing so that you don't miss out on one of these in the future. But all in all, have a good one and see ya.